In this video, we are going to talk about the counting principle. So the counting principle is used when you're trying to find out how many options you have given separate categories. So let's say you have M options from category 1, N options from category 2, and P options from category 3. Then you multiply those options together to get your total number of options. So M times N times P. It seems kind of weird talking about it that way, but I think if you see an example, it will make more sense. So let's just jump into the first example. My favorite restaurant offers a special in which you can pick an appetizer and an entree from a selected list of options for $9.99. The appetizer options are salad, soup, or chips and salsa. The entree options are grilled chicken, sandwich, Alfredo pasta, or baked potato. How many different lunch combinations are there? So you have two categories. Category 1 is appetizer, and in that category there are 1, 2, 3 options. So there are 3 options in category 1. Category 2 is the entree category, and in that category there are 1, 2, 3, 4 options. So 4 options in category 2. So you can mix and match those options to figure out how many different lunch combinations you can find. So one way to do this is you can make a list of all possible combinations. So you can put each appetizer with each entree. So the appetizer as a salad, you could pair with each of the entrees. So you could have salad and grilled chicken. You can have a salad and a sandwich. You can have a salad and Alfredo. Or you can choose a salad and a potato. So those are all the possible lunch combinations if you choose a salad. Then you could choose soup. So the soup you can have with each of the entrees. So you could have soup with grilled chicken, soup with a sandwich. You could have soup with Alfredo pasta, or you can have soup with a potato. And then you can do the same thing for the third appetizer. So chips and salsa, I'm going to abbreviate with S or CS. You can have that with the grilled chicken. You can have chips and salsa with a sandwich. You can have chips and salsa with Alfredo, or you can have chips and salsa with a potato. So I've now systematically made the different lunch combinations, and if you count them up, you can see that there are 12 different possible combinations that I could choose from when I have 3 appetizers and 4 entrees. So this works perfectly fine. You can do this in any situation. However, it's not really realistic to make a list if you have a bunch of categories and or a bunch of items in each category. So for example, if you could choose maybe a 3-course meal where you had an appetizer and an entree and a dessert, and you had 10 appetizers to choose from and 20 entrees and 5 desserts, it's going to take you forever to make a list, and then you're not even going to be sure that you got them all. Like, what if you missed some combination? So this is a possible way to do it, but it's not realistic. So let's look at another way we can go about solving this. So a second way to organize the information is to make a table. So the table, what you do is you put one category as rows and the other category as columns. So for example, you could have the appetizers category here. So the appetizers are salad, soup, and chips and salsa. So that makes up your rows. And then the columns will be made up from the entrees. So the entrees are grilled chicken, sandwich, Alfredo pasta, and the baked potato. And so you can see that you're going to have some combination, right? So this is where salad meets the grilled chicken. This is where salad meets the sandwich. So forth, right? So you can see that you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 places where you'll have intersections between these two categories, which means you have 12 options, right? So each cell that you fill in from the chart gives you a possible lunch combination. So this is an organized way to make sure you don't miss any. But this is only good if you have two categories. If you have a third category like desserts, where are you going to put it? You can't really make a chart. It's also not realistic, again, if you have a lot of entries in each category. So let's look at a third option. Third option is make a tree diagram. So if I make a tree diagram, I will start with the possible options for the appetizers. Drew a blank there. So options for the appetizers, and actually let me start it over a little bit further. So salad, soup, and chips and salsa. And then for each of those, so lunch combinations, each of those branches off into one of the 4 entrees. So we had grilled chicken, sandwich, Alfredo pasta, and baked potato. And then we have the same thing for the soup. So the soup can branch off into the 4 entrees: grilled chicken, sandwich, Alfredo pasta, baked potato. Same for the chips and salsa. So grilled chicken, sandwich, Alfredo pasta, baked potato. And so once you get all the branches on, see now this one, if you had a third category, like let's say we had desserts, you would branch the desserts off of each entree. And so you would just keep making branches for each category, and you would do that for all of the branches. Okay, but we don't have desserts this time, so we just stop there. What you do now is you count how many branches you have. So there's 4, 6, 7, 8, 9, 10, 11, 12, and so you would know that you would have 12 possible options for lunch combinations. So this one will work for as many categories as you have. The appetizer, the entree, you could have a dessert, you could have a drink, etc. So the tree diagram is a better way to organize, especially if you have more than 2 categories. But again, it's not realistic if you have a bunch of items within each category. So what you really want to do is look at using this last method, which is the counting principle, and all you have to do is multiply the number of items within each category. So for the appetizers, you're going to do appetizers times the entrees. There were 3 appetizers to choose from, and there were 4 entrees to choose from. And if you multiply that together, you get the number of combinations. So it's not like a difficult concept, right? And it doesn't take as much time as the other options. All right, so now we're going to use the counting principle. We're not going to do a tree diagram or a chart. You're buying a new car and have several options to choose from. So options, categories. First, you can choose basic, upgraded, or luxury package. So here is category 1, and it has 3 options. So category 1 has 3 options. Okay. Times category 2, second, you can choose to have a sunroof or no sunroof. So there are 2 options there. So category 2 has 2 options, sunroof or no sunroof. Third, you can choose to have 4-wheel drive or no 4-wheel drive. So that's 2 options in category 3, 4-wheel drive or not. Okay, then we have fourth, you can choose the paint color from 6 available options. So we have 6 options for category 4, and here they are listed out. So 6 options for category 4. Okay. How many total options are available? So you just write down each category and how many options are in each category, and then you multiply those together. So 3 times 2 times 2 times 6, I believe that's 72. The next thing we want to talk about is factorial. So a factorial is a way to write multiplication when you're multiplying consecutive integers. So for example, again, I know it doesn't make as much sense when you have the variable, but let me just show you an example with numbers. Let's say I had 5 factorial. What this means is you're multiplying 5 times 4 times 3 times 2 times 1. So you're decreasing by 1 each time, and you're multiplying all the way down until you get to 1. So 5 factorial means multiplying 5 times 4 times 3 times 2 times 1. And when you actually do that multiplication, you get your answer, so 120. This can be done with any whole number, so like 4 factorial, that would be 4 times 3 times 2 times 1, so that would be 24. So, just an easy way to do that. And obviously, it's beneficial, it saves time, but it is really beneficial if you have a huge number, right? If you have 130 factorial, you don't want to write 130 times 129 times 128 and, etc. That would take way too long. So this is a very efficient way to write this type of multiplication. So let's see how we could use it. Number 3, my son's baseball team has 11 players on the roster. So part A is, in how many ways can the coach create a batting lineup? And I didn't say this, but let's assume he's batting all 11 players. So let's assume all 11 players get to bat. So how many ways can he create a batting lineup? All right, so let's see. There's going to be someone that bats first. There's going to be someone that bats second, third, fourth, fifth, 6th, 7th, 8th, 9th, 10th, and 11th, right? Okay, so there's the batters. So what you want to think about is how many options you have for each batting placement. So for the first batter, we have not assigned any boys to the lineup. So you have 11 players to choose from. So there are 11 options for the first batter. All right, second position, the second batter. We've already used one of the kids, right? We already have someone assigned as the first batter. They're not going to repeat themselves, right? They don't get to bat again until they go through the entire lineup. So one child has been used, so now there's 10 left to choose from for the second batter. Okay, so now we've assigned 2 kids to bat, so there's only 9 options left for the third batter. Now there's only 8 options left. And hopefully you can see the pattern is that each time you're losing one option, right? Because you're assigning one kid to that batting lineup. And at the end, you've already assigned all the kids except one. So there's only one kid left, so he's going to be the last batter. So you can see that this is the way you can figure out how many ways you can create a batting lineup. And if you notice you start at 11 and you go down each time, it's because you use one person each time. So this is an example of when you could use the factorial. It's 11 factorial. On your calculator, you probably have a factorial button, and you would just type in 11 and then that exclamation point, which is the factorial, and it'll give you your answer instead of having to type in all the numbers multiplied together. So it would be 39,916,800. That is a lot of ways to create a batting lineup. All right, part B. Assuming that the coach always wants his son to bat first, how many ways can the lineup be made? So we have the same lineup, but now we're forced into having the first person chosen for us. 6, 7, 8, 9, 10, 11. So here are my blanks. So if the coach's son is going to bat first every time, we only have one choice of who to put there, right? He only has one son on the team, so one choice. Now we've assigned him to be the first batter. So that only leaves 10 kids to choose from now for the second batter. Now we've assigned 2 kids out of the 11, so that only leaves 9 options. Now we've assigned another one, so that only leaves 8. And you can see that now we're back to that factorial where we're losing one each time. We're losing an option each time. But again, notice that that first position is a 1 and not an 11, and that's because we're forced to choose that person in that particular spot. And so that's just a 1. But 1 times 10 factorial, 1 times anything is just itself, right? So really what we have here is 10 factorial. So 10 factorial, that would give us 3,628,800 different ways to create a batting lineup if the coach's son always goes first. Okay. So number 4, in the 2022 Winter Olympic Games, 31 men competed in the big air event. In how many different ways can gold, silver, and bronze medals be awarded? So this time we have not three categories. Well, I guess kind of, right? We have a gold, a silver, and a bronze. So we have 3 places that we're trying to fill. We have 31 men competing. So the first thing you're going to do is fill the gold position. So we have 31 options of men that could possibly win the gold medal. Now, whoever wins the gold medal does not get to win any other medal. That's it. So that one person is gone. So now instead of having 31 to choose from for silver, we only have 30 options for the silver medal. People who place gold and silver are not going to also win bronze. So now we have 2 less options to choose from for bronze. So that would leave us 29. So notice this isn't a factorial because we don't keep going all the way, right? There's only 3 places, gold, silver, and bronze. So we simply fill in those numbers and multiply those together to get the answer here. So 31 times 30 times 29, and that would give us 26,970 different ways that we could choose gold, silver, and bronze medals from the 31 men competing.